I'm Professor Rad, and this is Precalc video 216, the difference quotient. So one of the really important concepts in calculus is something called a difference quotient. So we're going to talk about what it is and go through a few examples of simplifying the difference quotient, because it can be pretty algebraically intense at times and lots of little places to make mistakes. So let's take a look at the definition. So the difference quotient for a function f of x is given by this gorgeous formula here. F of x plus h minus f of x all over h. So here's where this formula comes from and why it's so important to calculus. So in calculus, one of the main driving inspirations is trying to figure out how to find an instantaneous rate of change. So we know about linear functions and how to find average rate of change. That's your slope. So if you have a linear function, you can find the slope of the line and see how it's changing at a particular point, or at any point really. What we want to do is take any function and see how it's increasing or decreasing at that particular value. That's what calculus is going to introduce us with. So where this comes into play, if you think about your slope formula, your slope is going to be your change in y, so y2 minus y1 over x2 minus x1. So what this is going to do, or be rather, is instead of using y2 and y1, we're going to continue with function notation. So instead of y2, you can think of that as f of x2. And instead of y1, you can think of that as f of x1. So in calculus, you're going to think of your slope formula in terms of function notation. It's the same slope formula you know and love, or don't love, but the one that you've become accustomed to using. Now, where this h comes from is h is a shorthand way of saying the difference between x2 and x1. So we're going to use h to represent this change. So h is going to be x2 minus x1. So what I'm going to do is I'm going to solve this for x2, and I'm going to bring x1 over to the other side. So I have x1 plus h is x2. The method to this madness here. So instead of this x2 minus x1, I can write that as an h. And since x2 is x1 plus h, I can rewrite f of x2 as f of x1 plus h. Since these are the same. And I'm going to subtract f of x1. And then, since we only have one x now in our formula, we don't need the subscript. So we'll just call this x. And behold, the difference quotient is born. So the difference quotient has its origins in our slope formula. And the reason we want to think about it in this light once we get to calculus is because what you're trying to do is you're trying to find the slope at a specific point. So what you're going to do is you're going to find 2 points that are really close together and find the slope between them. And you're going to try and shrink that distance between those points as much as possible. In other words, we're going to try and see what happens when h gets closer and closer to 0, that distance gets smaller. So having this defined in terms of that distance is going to be helpful. So that's a little bit of the background why the difference quotient is going to be really important in calculus, and it comes from our slope formula. However, these things can be pretty algebraically intense to simplify. So let's do 3 examples of simplifying this, just so we kind of get a handle for what it's going to feel like. Alrighty, so we're going to start out with a pretty basic example here. So we're going to find and simplify the difference quotient for a linear function x plus 4. Now, I'm going to tell you a little secret here. Because the difference quotient is going to be related to the slope, and we know the slope of this line is 1, ultimately, we should get a difference quotient of 1. So let's kind of test that secret, that idea. So this is our formula for the difference quotient. You do want to commit this to memory. And you can simplify all in one go if you like, or you can take it in stages. So for this one, we're going to take it in stages. In the next one, we'll evaluate it all in one go. And then for the third one, you'll get to practice and I'll work it out both ways on the board. So we can kind of compare the different techniques. So in the stages, there are really like 3 stages to this. We want to find this f of x plus h, because that can sometimes be really messy to find. Then once you get that answer, you want to subtract f of x from it. And then once you get that, you can divide by h. So those are going to be our 3 stages. So let's find f of x plus h first. For this function, we're going to replace x with x plus h. So x turns into x plus h, and 4 becomes 4. Doesn't change. Now I put this parentheses around x plus h so I can track my work, because like I said, these get kind of algebraically intense. So we want to make sure that we're following along what's going, like what's happening. But in this case, we don't need those parentheses there. So I can rewrite that as x plus h plus 4. So that's our f of x plus h. The next stage is to take that and subtract f of x. So we're going to take, let's do like a little bullet point here. And then the next stage would be f of x plus h. And we're going to minus f of x. Now, one of the things that makes this complicated is the subtraction. So you definitely want parentheses around f of x, because I can't tell you how many times in both pre-calc and in calculus we make mistakes by forgetting to distribute that minus sign. So please save yourself and your math teachers from lots of headaches and just put parentheses around that second one and then simplify. Take the second to do that extra step. So f of x plus h we found up here, x plus h plus 4 minus parentheses. Now we're going to write out f of x. So f of x is just x plus 4. Close those parentheses. All right, so now we can simplify this expression. So we'll distribute that minus sign. So we have x plus h plus 4 minus x minus 4. And then we can combine our like terms. So x minus x is nothing. H. 4 minus 4 is nothing. So we just get h. So we take this like really huge, awful looking thing here, and in this particular instance, it's simplified just to h. So now we'll do our third step, which is to take that result, and then we're going to divide it just by h. That's not too bad. That's 1. So there you go. So, and that matches kind of what our thought was. If this is going to be the slope of this and this is a line, then the slope matches the slope. So it works out. So now let's look at a function that's a little bit more terrifying than a line. Let's look at a rational function and try and find the difference quotient for that one. For our next example, example B, we're going to find the difference quotient for g of x, which is 4 over x. Now, just because we have g of x instead of f of x this time is no big deal. We're just going to put g instead of f. Same process. Now, this time when we go through it, instead of working it out in 3 different stages, we're going to work it all out in one go. So you can kind of get a feel for what the difference in the type of work is going to feel like, and you can make a decision for which type you prefer. So let's begin. So we need to find g of x plus h. That's our first part of the difference quotient. And then we're going to subtract g of x. And that will be all over h. So that's going to be our difference quotient formula. Next, we need to find g of x plus h. So we're going to go into our function here, 4 over x, and we'll replace x with x plus h. So we start out with 4 over x plus h. Then we subtract g of x, which is 4 over x. And this is all divided by h. Okay, now we simplify. So simplifying is the, super fun part of this one. What I'm going to do, there are a few different ways you can simplify this complex fraction, but in this case, what I'm going to do is I'm going to multiply the big numerator and the big denominator by the common denominator of the little denominators. So what that means is I'm going to multiply the big top and the big bottom by the common denominator of these two expressions. So the common denominator for these two would be x times x plus h. So that's what I'm going to multiply the big numerator and the big denominator by. I have to make sure that I multiply the denominator by that because I need to be multiplying by 1. So this is really just a secret 1. When I distribute this to the first rational expression, the x plus h will cancel out, but the x will remain. So I end up with 4x from this first piece, and down my minus. And when I multiply x times x plus h times the second fraction, the x's cancel, and x plus h remains. So I have 4 times x plus h. Then in the bottom, I just have h, x plus h. Okay, so now it's just a matter of combining our like terms in the top after we do some distributing. So I'm going to distribute, watch the sign, a -4. So that's going to give me 4x minus 4x minus 4h all over hx x plus h. Now these 4x's cancel out. So we end up with just -4h up top. And then we have hx x plus h. hx x plus h. Now in our numerator, we just have one term, but that term has two factors. It has a factor of -4 and a factor of h. In the denominator, we also have a factor of h. So this factor of h and this factor of h can cancel out, and I'm left with -4 over x times x plus h. And there we go. That's going to be the difference quotient for this rational function. Oh boy, right? So very different. We didn't get 1 at the end like we did in the last example. So our answer here has x's and h and numbers. So you can go all kinds of different types of answers with your difference quotient. And you want to take it one step at a time as you go through to simplify. So whether you do that one step at a time, kind of separate it out like we did in example A, or if you be very methodical about how you're substituting in here, maybe using different colors like I did to kind of follow the track more easily, you can absolutely do that. But you do want to be careful with these because it's really easy to make hasty mistakes. So I'm going to put one more example on the board and then give you a chance to work through it. And then I'll write my solution both ways so you can kind of get a sense for what that one would look like using both of the two techniques. All right, so for this third example, we have f of t is equal to t squared plus 4t. So if you would like to pause the video here and work through that, get some practice using the difference quotient formula, and then also using the technique that you prefer, see what you get when you evaluate it. And then you can unpause and I will have both solutions on the board behind me. So pause the video here and work through it. All righty, how did you do? So this one was pretty cruel. So I do have twice the work here. So what I did up here on top was I found capital F of t plus h. And then here I subtracted capital F of t from that. Now, if you had x's instead of t's, that's okay. And then here I divided by h. And in the end, I got 2t plus h plus 4. So if you want to pause the video, if you use this method, you can pause the video and kind of inspect more closely which parts, kind of check your work more precisely. And then on the bottom here, I have the same problem. I just worked it out in one chunk. So I did f of t plus h in black, f of t in blue, and I kept the h in green until I got over here. And then I just finished simplifying and got the same result. Same thing, you want to pay careful attention to where your work may have been different from mine. One of the common mistakes with quadratics is distributing an exponent instead of multiplying out. So if I have t plus h quantity squared, that's going to be t plus h times t plus h. And so when you FOIL that out or you multiply it out, you get t squared plus 2ht or 2th plus h squared. So you do end up with this middle term, so you can't just distribute exponents. So I'm going to get out of the way so you can check your work and pay careful attention to where a mistake may have been if you made a mistake. And if you didn't make any mistakes, that's nice. Means you got it. Okay, so that's going to be it for this video on the difference quotient. In our next video, we are going to look at some nonlinear inequalities. So we're accustomed to solving linear inequalities basically the same way we do equations, right? Just be careful when you divide by a negative. But if our inequality is not linear, if it has like x squared or has a rational function in it, then we need to be careful of a couple of other things. So we'll look into that in the next video. In the meantime, I hope this helped with the difference quotient, and I hope you have a wonderful day. Bye for now.